So once we have enabled telemetry streaming via RackAdam or via Redfish or the script that had been provided previously during the setup steps, we can now go and download the repository, which has the scripts for hooking up to the iDRAC and for entering the data into a database. So we just do a git clone of this repository. And in here we have a few different scripts. First of all, in order to run these, we need to have the environment set up. And this is the same type of environment that has been set up previously with Python 3 and the VENV, the Venv virtual environment plugin or module. For those who are interested in that, can go and have a look at the how to enable the telemetry streaming feature using the script, because setting up the virtual environment was explained in there. Now, in order to get Python the right modules, we have a requirements file, and we will simply use that to get everything set up. So run pip3 and point it to the requirements file, and it will install everything for us. Primarily what we need is the request module and also the InfluxDB part. The rest are kind of additional, but it's always good to have the same versions to make sure it works. Now, we're going to edit this Python file. In order to do that, we are using FileZilla to connect to the server, because it's a headless server. And once we do that, we can go into the directory that we have here and just right-click File to edit it. Using Visual Basic Code for this, but any editor will do, of course. So in this file here, we can see what we're doing. This is the basic one, where we are simply pulling the information from the server using Redfish server sent events. We enter in our IP address, username, and password for the iDRAC. And then we simply go to this metric report URL on the server. And that is exactly the same one that we used to check the functionality after enabling the telemetry streaming feature earlier on. So there's nothing magical going on there. We're just going to the same web address and downloading the events from there. You can use a certificate if you want. I recommend to if you want to, but you have to download it from the server first. So I'm just going to use the script here. I'm just going to update the IP address locally. We could have sent it over with FileZilla, but whatever, this works too. And the reason we have this basic one is just so that you can see how you can get the data in and what format it comes out of. As you can see here, we don't use a certificate, just the IP address, and that's why we get that warning. Now we get data fairly soon. Sometimes it can take a bit of time, so be patient. It can take up to 30 seconds to a minute sometimes. Now, in order to parse this, I mean, this is coming out almost as JSON format, but not quite. So we're going to just use JQ, install that, so that we can parse it. I'm just going to copy and paste one of these entries. And just to show you how it is set up, we're going to just cat that into a temporary file. And in order to make it proper JSON, we have to change the single quotations to double quotations. As you can see here, JQ isn't going to work with single quotation marks. So to do that, we use the sed editor, so we cat the file. We use a sed editor to change single quotations to double. We can't enter single quotations inside the sed command as such, so we use x27, which we escape, and that will do the same thing. That is basically a single quotation there, the x27 part. So you can see now single quotations have been changed into double, and now we can put it into JQ, and it will show us the architecture of this. So we got the metric IDs, we got the actual value, and then we can see in here during the underneath the OEM, Dell, and label, we have a little bit more detail on what this is. So in the case we are just looking at the airflow, but this would work for anything. So next step is to add the database. You want to store the data somewhere, obviously. I just made a little cheat sheet here, which will be uploaded to the web page, so you can see it there, and also put us in the description of the video. I'm just going to copy and paste here. We install the requirements first for Docker. And in this case we're using I think 1904 of Ubuntu. Let's just double check that with LSB release. 1910, close enough. You can see here the code name is E1, and that's why I have that in the command here. You can change yours to whatever it is that you're using on your installation. There is a 2010, I think, of Ubuntu released already. So we just add the repo and update, so we get the latest pointers to those repos, and then we can run the actual installation of Docker CE, CE being the community edition. So now you can see Docker is there, but we need to also give ourselves permission, otherwise we get permission denied. So we do that with user mod and add ourselves to the Docker group. Now you would normally have to log in and out again to get this, so we're just going to open another shell inside this shell, kind of double back on ourselves, and then we can see here that it's possible for us to use this, since essentially it's a new session. Now we don't have any containers running right now, so that's why it's empty. Since it is a new shell, we're going to have to jump into our virtual environment again. You can see that it's active now. So now all we need to do is to download the InfluxDB container image, and we do that by using docker pull. And that'll download it from GitHub, or not from GitHub, from Docker Hub. And once that is done, we can launch the container with the settings that we wish to have. We can check that the image is there now with image.ls. And as you can see here, we can now launch then the container. We're using D for detached. We give it a name, InfluxDB. We set it to a port. The default port is 8086. We want to create a database, so we do that automatically here, saying that it's telemetry. We add a root user or an admin user and give that user a password. We also enable HTTP authentication, and the reason we're doing that is that we want to connect to this database from the outside using Grafana with a HTTP connection. And then finally, the InfluxDB that you see at the end is the name of the image that we just downloaded. And that is very fast. Now it's up and running. It only takes a split second. So if we do a netstat, we can check is that port actually being listened to, and so 8086 should be in there, and it is. That means it's up and running and good to go. It can be nice also, of course, to verify that the database that we wanted is actually in there. We can do that by launching a second container, or to execute the client inside the InfluxDB container that we launched earlier. And the client is called Influx, that's what we're executing now. So then we can verify that with show database that we do have that telemetry database that we created. And of course, when we log into this, we're using the root username and the password that we specified as well. So that is validated just by being able to log in. Made a typo there, actually I got to update that. Not show DB, it's use DB. And show measurements will show you what is actually in there. Right now we haven't entered any data, not yet. So we're going to run a second session to the same server and run that script, the Python script, to enter some data, and we'll just keep the other one in the background so that we can verify once data is in there and see what actually gets added to the database. So in this new session, we enter the virtual environment. We go into our directory where we have the Python script, just like before. Let's go with FileZilla and see if we can actually edit that file as well. That's the same directory. So you can see now that this is a little bit more than the basic. We have the addition of the InfluxDB part. We also have some requirements there to take the InfluxDB settings from our OS environment. And that saves us from having to enter it into the Python script itself. But that of course means that we have to load that into our environment, and I'm going to show you how to do that in a moment. We can also label this data with like a device and location and everything. So every time we do a write to the database, it is labeled with that. You can make up your own. I'm just using a couple here that I thought would be descriptive for what we're trying to do. We want to update this to the correct IP address of the server. And we are still not verifying the certificate. We're doing some additional stuff in here for the CPUs, so that you get it per core. And in the end, when we get this, we have, as you can see, we're pulling it up from OEM Dell label and to get the label for it, and then we have the metric value there as well. So we're just going to now save the file, and if we click yes here, it will update the file on the remote server. So if we go in here now and we check, actually we can just cat the file and check that it has our name, also the server IP address in there, and it does. So if we run this now, first we need to make sure that we have the environment sorted. So if you check the environment now, we don't have anything there for InfluxDB, so we do need to load that. So we have a file that is already set for that, that matches our local environment. So if we cat that, you can see it just goes through and says export, and then each one of those values that we need. So in order to import these settings or add them to our environment, we have to do something that is very similar. Actually, we have to update this first. So it's set to 31, right, which is wrong. Our IP address is 42, so just edit this, update 31 to 42, and the rest should be fine the way it is. Now when we jumped into our virtual environment, we have to source activate the environment file. So we're going to do something similar here now to add this, the database name, the username, and the password to our environment. So we just do a dot and then add on the local script there, the load environment local. And then you can see once we update our environment, we can check that those values are now part of our session. If we now run the script, it will still complain about the certificate, but it will work. You can see now we're getting some data in already. And if we, in the InfluxDB console, go again and check for our measurements, you can see here now that we do have some new values. We have a new collection of measurements. You select everything from that. We're going to get a lot of different data. Obviously not very useful in this shape and form, but we can have a look at the fields. And then we can see then what type of data we got in there. So we got some fan speeds, we got some CPU information, and the memory temperatures for each socket. And we of course want to visualize this. So to do that, we add Grafana as a second container on the same host. We do a Docker pull first to get that downloaded from Docker Hub. I'll sped that up a little bit. You don't have to wait for it. You can see now that we now have the Grafana container image in addition to InfluxDB. And to run it, it's much simpler than InfluxDB because we're not setting any specific settings. We're just running it on port 3000. You can see now that it's up and running. So let's go and create a new dashboard. So go to the IP address, and we add the port 3000. And we can log in. A default username and password is admin or lowercase. We can update that here if we wish. The first thing we need to do is to add a data source. The data source that we want in this case is InfluxDB, because that's what we just set up. It does support several others too. And here you can see the reason that we added HTTP authentication to InfluxDB when we launched the container is that we can connect to it this way from here. You just add the IP address and the port. We enable using credentials connect and add in the database, username and password, just like we did when we launched this container earlier on. So it's just root and pass in this case. So now we can verify that. We'll see if it works. And that looks like it's actually good to go. Now we can go and create a new dashboard. First thing to do is to add a query. And we add it now from, since we're connecting to the InfluxDB, it shows up here automatically. You can pick a location. So those are those labels that we looked at earlier on. That's where they end up. We have a lot of different fields to select from. We'll just pick a value from CPU. By default it's got this mean value, but we want to change that to distinct. We can see that already we got data in the database, some values there. We can change this type to single stat or to gauge. I guess it's easier to see the CPU temperature through. And we want the last value, not the mean value. It's the temperature value, so we add that, Celsius. And modify this a little bit so that we can get the min and max values. You can just make something up if you want. Of course, the defaults in here is kind of boring, so we're going to speed this up a bit and add some color to it. That looks a little bit better. The panel title needs to be updated to match what it is we're trying to do, so we add that now. We can pick then if we want it to be transparent or not. So this is essentially it. It's very easy to add. Then just go through all the different variables that you want, add them in here. You can click on this to actually duplicate what you've done if you want to have more of the same thing, and then modify them. So let's say we want to have the same values, we just want to have a graph. So just go in there and change the type to graph. The database connection is the same. You can change the color if you want. The color change can be difficult to find unless you know it is actually hidden there. You had to click just underneath the graph to change that. And look at the last 5 minutes of data, and we just started this off, so there's not much data in there. And we can add more data. We just added a few more, like the temperature of the power supply, the first one, and some of the fan speed. In the end, we can set this to automatically refresh itself every few seconds or so. And if you work on it a little bit, you can build a dashboard out kind of like this.